Hey guys, today I'm going to show you how to draw your own custom cat ladder, create your own custom cat ladder in Revit and also edit it like this. We say edit and we go here and change that to 10 meters. It will change your cat ladder and everything will snap with it. Hello guys, welcome back to my YouTube channel, Revit Wiz here. So let's get on with it. File, we want to go new family. We want to look for the metric generic model, but you can also use the wall based. I just like working with the generic model. Then you can place a cat ladder any place you want to. Will it be against a column or anything like that? Even against structural steel. So let's open this. And now we want to start setting up our cat ladder. So I'm going to bring in a CAD drawing, just the layout of my cat ladder, so it's a lot easier to draw. You just select, you can preserve the colors or you can have it black and white, and then just say whatever your import unit is, and I just say manual center and then continue. Okay, now I'm just going to move this to the center and then move this also to this reference line, and I'm just going to pin it here at the top, PN. Now I just want to draw in the plates. So I'm going to create an extrusion for these two side plates here. The reason why I do them together is so that they work as a unit. I'm going to show you now. So let's go to the 3D. I'm going to do that. So the reason for that is, so if I pull this up, you can see it actually pulls up both of those elements. Okay, let's go back to the floor plan. Now I just say CS create similar, and I also want to draw in these small plates here. Like that. These plates are smaller than the plates that I've drawn first, that's why I'm grouping them together. And they also need to be at different levels. That's the other reason why I'm grouping them like this. Okay, let's say okay, and then we go to the 3D to go and check that out. I can see we have something like this, and this plate actually needs to go up like that. Okay, so now we have this set up. Now we're going to just put in some parameters. So let's go to the front view. So we always work with reference planes, so you press RP for reference plane. I'm going to put it in here at around about 5 meters. There we have it. And I'm going to say AL, click on this line, and I want to align that there so that it locks. That's what we want. Then I'm just going to pull this down so you can just distinguish between what's going on here. Now I'm going to put in another reference plane at this level here. So I'm going to make that 2350, or 2325 rather. That's just the level that the height of the cage actually starts. I'm going to pull this up, then it's going to ask me, do I want to lock it? And I'm going to say yes, I lock it. Then I want the cage to extend 1.1 meters beyond the level that I enter onto. So I want this cage to go up like that, and I lock it there. Now we can actually go and add in the dimensions and then give them some parameters, the parameter data. Okay, so that is what we want to do. This one, so that's the height above level we enter, this is the height at which the cage must start. And then we're also going to have the full height of this cat ladder. But we want the cat ladder to actually start just a bit higher. Let's make that 115. I'm going to move this up so it snaps, and I'm going to lock it. So I can also give this dimension. So the reason I give this certain dimensions and then parameters is so that you can change it later on if this is within your model. So this height I actually want to start from that level. So I want to maybe make this 6 meters just to have a round number. Seen that one did not snap how it's supposed to because we haven't given it parameters yet. So let's just do that and make that 1.1 again. Okay, now I click on it and I say create parameter. I leave everything as is, and I'm going to say extend of table. You can name it whatever you want to and make sense to yourself. This one I'm gonna call cage height of ground level. Like that. Okay. And then this one I'm just gonna call height because I know that that's the height of my cat ladder. And that one I'm just gonna create parameter and say plate above ground level. Like I say, you can call this whatever you want so that you understand what is going on. Okay, so let's create the rod. So what we're gonna do is go to file, say new family, and we're going to do a generic one, the same one that we actually have open, but just create a new one. Now we are in the reference plane, but we want to be, let's say, on the left side because we want to create a circular section. So I'm going to say extrusion, circle. I want to click there and I make it 10 because that's the radius. So then the diameter would be 20. There we have that. So let's just make sure if you click on this, it says not a reference. We want to make this a strong reference so that we can align it with elements. So let's just quickly go to the reference level. So now we just need to make sure that it's the correct distance. And that distance that we want there is actually 770 mils in total distance. So we just make this 385, mirror to that side because that's half of the 770. Let's lock that one and lock that one. There we go. Let's just have a look in the 3D view. So it's a basic rod like this. Now we just want to make this, change the category here. I'm going to change it to the structural steel, the S355, whatever structural steel standard you use, so that we know this is steel. Once I just say fine and realistic, you can see that it's a structural steel element. Now we're going to load it into our family, and I'm just going to place it here. Now we can go and align it to this reference plane I've created here, like that. And I can just align it to that portion there. So let's go to the 3D, and where is it placed? I think it's at the bottom. Yeah, there it is. Okay, so now we're gonna just make it neat. I actually see this needs to move upwards to there. Lock it because we want the cage to extend like that. Let's go to the front. Now I'm just gonna move this upwards like that, and then put in another reference plane here that I want to make, see it 200 like that, and I'm going to align this See it now. I can align it on the central axis due to making that reference a strong reference. Now I want to array this to the level that you actually enter onto the certain slab or access level you require. So I'm going to click on this and I say AR for array, and then make sure that last is ticked here. And I'm going to click on that reference center and then take it up to this reference here. Now we have those two. Now I just want to align this AL to that so we know it's locked. So it is always between this specific distance. Okay, so now what we're going to do is we're going to create a parameter. So you click on the array and then you click on this line here. So this label pops up and then you say add parameter. Now I'm going to call this number of rods, rather rods spacing. Okay, now it's still 2, but we can go and say, okay, we want to make this maybe 3 or 4, but we want to use the formula to do that. So we're going to go to family types. Now you'll see this cage height above ground level. These 4 we have entered our parameters earlier, and then the other is the rod spacing we've created now. But now we want to say, okay, like I said, we want this to be spaced between the ground level basically and the level that you enter. And we're going to have to do a formula. So we're going to say bracket height minus extend above ground level, rather extend above level, close the bracket, and then we're going to say divide by 200 millimeters and say apply. And there you can see it's generated our spacing for us. Okay, let's just change this to 100 like that. And then we check this one is 100, but I want to add a parameter to say first rod above ground level, like that. Then let's see if we change this to 115. See, now you can navigate this in your project as you want. Let's see, that's 192. We actually want it spaced at 200 mils. Let's see if we go here and we say round up that. Take out the +1, say apply. Just take out the millimeters, say apply. Still not. Maybe it's because we don't have the brackets in. Like that. There we go. Let's just see the dimension now. There we go. That's the 200 that we want. Great. So let's go to the 3D so I can show you how it looks. That looks quite neat. Now we need to form these rings. But before we do that, let's just set some parameters here as well. So let's see if we do that and that, so that we can, let's just align it to this one. Let's see what that dimension is. 790. So that would be your width of your cat ladder. So let's say here parameter, call it width. So okay, then we can just do that. You always make sure that is equal. There we go. Like I say, now we want to put in this ring, but now we need to make a new family again. So go file, new family, and also generic family, generic model, say open. Okay, now I'm just going to insert the same CAD file that we've had earlier so that we can just, we don't have to redraw this, we can just pick lines. So just to make it easier for ourselves. So we can place this anywhere where we want, but I want to place it in the center because I like doing that. So we just want to create this outer ring. So what we're going to do is say create extrusion. Let's just, before we do that, add in a reference plane. Yeah, that. Okay. Now what we can do is do the extrusion. So we'll say pick lines. I'm going to literally pick these lines that's already been drawn in AutoCAD. So it's a lot easier if you do already have a cat ladder set up in AutoCAD format. Say okay. Let's go to the 3D. So this is how it looks. This is obviously a lot thicker than it should be. So we want this, I know the plate is 50 mils, so let's make that 50 and bring this down and just lock it. Okay, let's go to the 3D again. There you go, we have one of our rings. So we can also add parameters here if we want to. Let's go to the reference plane and then say reference plane like that, just align it on the edge. So we can do this, we can call that the width, just call it W. This one we can call like that. We can call the depth, D for depth. Okay, let's see if I do edit this. Let's make it 800. See, it snaps with that in the background is just the DWG. Okay, so we can delete DWG now. Don't need that anymore. Like that. We're gonna load it into our family, our cat ladder rather, which is this one. That's the wrong one. Ek moet hom net gehoor begin. Okay, let's just load this in, load into our cat ladder that we've saved. Okay, so now let's go and see in the 3D where it's actually placed it now. Go families, generic. That was family 4, I believe, that we've added. Let's just see if I pull this in. There it is. Okay, so let's go to the reference. Now what I'm going to do is I'm just going to align it with the existing DWG background like that. There we have it. Let's go to our 3D view. There it is on the ground. Okay, front view. Now we're basically going to do a similar exercise what we did for the rods. So I'm going to just move this up. I want to align this to the bottom of this section, and then I'm going to array it AR. Then what I'm going to do is I'm going to make sure it's on last, and then I'm going to click here. Let's just use the top, or rather let's use, I'm just going to do that again, AR. Let's use the center. I'm going to go up here, And then I'm just going to align it here. Okay. Now we also have two, but we want to make our own parameter. Let's say this is ring, we'll call it cage ring spacing. Okay, go family types. Then we're gonna have to do another formula again, but in this instance, we can actually say here we want the height minus the cage height above ground level. So cage height. Just make sure you type in capital letters where there is capital letters, otherwise it won't pick up the certain parameter. Close it, and I want it spaced at 900 millimeters. Apply. Let's see. Okay, let's see what it did for us. So let's go dimension. I can see it doesn't want to snap to the center line here. So we can go back to our reference that we've created. Let's just go to the front view maybe. Yeah, we're going to add our own reference plane here in the center of this specific element, and we're going to say we want it as a strong reference. Well, apologies, I'll say strong reference. There we go. Let's just double check. That's it. Yeah, where we can actually also just make this category material also steel. So it just speaks the same language. So we're going to load it again to the cat ladder. This is quite trial and error as you go, and you want certain elements set up correctly. So let's go to the 3D. So here we have, let's just make this shaded so you can see it's all structural steel. Okay. Now we can just quickly go and double check what that spacing was. Let's go here, front. See, now it snaps to the center because we've given it the strong axis. So now we have 1.247. That's not what we want. So let's go again. And here, at the end of our formula, we're going to say +1. Even maybe +2. Let's see what happens. 748. Let's say +1. See, we want it 900 or less. Okay, so let's say we're going to also do the round up formula for this one. We're going to say round up your bracket, and then bracket at the end as well, like that. So let's see what it does. Let's just see, we always want to compare previous versions. Okay, let's see if we say at the end here +1, makes it 748. Divided by 900 +1 equals 748, but we want it rounded up. So let's just see, apply, okay. You can leave it at that spacing for now. Just see here. It looks fine. You're still within the standard, so we're okay. So now that we've set up all of this, it actually looks like a cat ladder now. So I can show you if we change, let's see if our cat ladder first works. So let's change this maybe to 10 meters and see what happens. Now you can see this level has stayed 2325, which we want because that's always a set level. Then it's snapped up with the extents above level. That's what we wanted. So let's see what this distance come out to. 858. So as long as it's not more than 900, then we're okay. So let's go to the 3D. There you can see our cat ladder is extended the way we wanted it to. Okay. So now I'm just going back to all the references or the generic models we've created. So I'm just going to close this. You can obviously save it. I'm not going to save it for this exercise. I'm just closing all of them just so that we can have some cleaner pages. Okay, that's okay like that. So now what we want to do is we actually want to give this a support or a end plate that fixes to something. So it can't just hang in the air like that. Okay, we're going to have to create another generic model. So we go File, New, Family. Then I'm going to scroll down here. Maybe I went past it now. Yes, generic model, open. Okay, once again, just going to insert the CAD. It's just easier like that. Just so that I know the plate distances. Just gonna move it to the center again, like this. Okay, now I want to basically do the end plates of this specific structure. Let's just align that. I see it's not properly aligned. There we go. Okay, so we want to draw it in from the front elevation. So let's just draw ourselves a reference plane so we know where our center lines are. Okay, let's go to the front. Now we know where the center lines sit. So now I'm going to draw a plate from the top of my head. So I'm going to say create extrusion. I'm going to do a rectangle here, something like this. Let's make that 165 and we can make that is 80. That's exactly what I envisioned, 40 and 40. That's great. Then I'm going to just mirror this over to here like that. Okay. So I'm doing the plates all together. So let's go, say finish. And then if we go to the reference level, I want to make sure, actually, sorry, the floor plan reference. I want to make sure this extrusion is sitting at that specific thickness, which is 6 mils. Now we go back to the front view. Now we want to create the bolts. So we're going to say create. Where is the extrusion? A circle. Then I'm going to create, we want 12 mil bolts. So it's 6 mil diameter. It's going to make sure I move this 25 mils like that. Then I'm going to DM it for the mirror around the axis. Those two are going to mirror it to here. There we go. So, okay, we go to our reference again. Now this is a bolt. We want the bolt to go into the fixing area, which could be anything, a wall, concrete, whatever your fixing detail is. Front elevation again. And now what I want to do is draw in the plate that actually connects to the vertical plate. So we're going to create extrusion again. Going to do a plate like that. This one I'm going to make 8 mils and the depth here 65. Now I just want to place it to the central point like that, and there. Then I'm going to just mirror that to here. So okay, and then we go to, it's a lot of jumping around, but as soon as we've set this up, you're going to see exactly why we did these things. I snap it to here because that is where I want it to be fixed to. I see this plate is actually a bit bigger, 10 mils, so let's just correct that. So edit, just gonna make that 10 mils, so I need to just respace or recenter it rather. It's just easier to mirror that again. Okay, there we have that. Double check in our floor plan. We still have it there. That's great. But that one we actually want to move a bit back so that it fixes to the 6 mil plate. I will show you it in 3D once we have drawn in everything. Then I want to do plates, some stiffener plates in the other direction. Something like this. I'll make that 6 mils. Just gonna center this. Just gonna pull it away so I can just get the center. There we are. Like that. And mirror it around there. Okay. So finish. We go to our reference plan again. And here we want to snap here because that's where our plate ends, and then this one just a bit back. And there we have that. So I see it's a bit bigger, but that's okay. We're doing our own plate. So let's go to the front view again. Okay, so there we have that. Let's just see the 3D. This is how the plate is drawn. That is what we want. You'll see the bigger picture once we actually import it into our drawing. So what I want to do is just make the bolt look a bit neater. Actually have the nut around it. So I'm going to create another extrusion. And this I'm just drawing from the top of my head. 10 mils like that. And then I want it to go here. So then what I'll do is I'll just mirror this so it's identical around that axis. Same with this one. Something like that. Might look a bit odd. Let's just move that a bit up so it maybe looks a bit better. Just see here. It's always so much easier to actually mirror something like that so it's identical. So this might look a bit bulky, but that's fine for now. I'm going to EM this around the central like that. So finish. We go to the reference level, not the ceiling plan one, the floor plan. Then I'll just pull this in so it displays as a nut like that. Just gonna move it maybe a bit more, something like that. Let's see. See, that looks like a bolt. Okay, so now let's load it into our cat ladder family. Okay, before we do that, always forget we must first delete the DWG in the background. Let's go to the correct one, like that. Then we're going to say load again. We're going to overwrite that, yes. Okay, family 5, just pull it in like that. See, there we go. I want to move it to that center point there. So let's go to the 3D view. Here we go. So I can now set my parameters. Let's go to the front view like this. Now I want, let's say I want that to start from the ground level, the first support 300 millimeters high. So I'm going to align that. Okay. This is why it's always important to do a reference plane in the center of your areas you want to snap to make a strong reference point. Okay. Load it again. We can just overwrite that so we can make sure that we snap to that center line. See, there we go. Like that. Now once again, okay, let's just go to the 3D and see there our connection is. So now what we can do is just go to the front view and actually move this in or move this up with the, sorry, this is the wrong view, into that view and that front view. So we want to do spacing at 1 meters to this specific level exactly the same that we did with the rods. So we're going to say AR, click on this, move it up to that point. Just going to align it so it's locked. There we go. Then I'm going to just click on that line again. Go to add parameter, number of supports. Then we go family types again. And now we're going to just do another formula, which is basically the same as the rod spacing. So we're going to just copy the rod spacing, paste it, and instead of 200, make it a meter, which is 1000 millimeters. There we have our spacing. Let's go to our 3D view. There you have that spacing, which looks great. Okay, so now once that is done, we can go to the front view again. But this connection is going to sit beyond the area that we want it to sit at. So let's just make a reference plane here and give it a parameter. I'm gonna make that 200 mils and call this let's call it last support offset, like that. Now let's see if we align this to, yeah, what happens. No, we want it other way around. Remove. So now it's still spaced at the distance we want, but it's at this offset. So let's see if we change this level. Always have to double check ourselves if all constraints are fixed. Yes, it is. You can see that's what we want. Okay. So the reason for that is so the support actually fixes into the brick wall and not beyond the brick wall somewhere in the air. Okay. Now we want to create, let's just go to the 3D. We want to create an extension here, like a U-shaped type of thing, so that you can climb onto the platform by assistance of this frame and also have it fixed onto the slab. So how we can do that, we go to the ceiling reference plan, going to copy these elements over like this. I'm going to move it, let's say 300 mils, like that. So let's go to the 3D to show you what I want to achieve. So I'm going to move this up. Does not want to click on this. There we go. I'm going to move it up here. We can just correct it now. So we go to the back view. So we can see that and move this down so it locks to our extents above. And just going to do that so that one locks. Then what we want to do is in the ceiling plan, we want to actually connect these two verticals now. So I'm going to create an extrusion from that plate, the vertical plate, to this vertical plate, like that. I'm just going to mirror that to the other side and say finish. Then if we go to the 3D, sorry, that's not the correct one. This is the correct one. This one is probably on the ground. Yes, it is. We don't want it here. We want it to move upwards. So we're going to move this. Just wants to work with us. We're going to move this up. Now it might look very odd at this stage, but there is method behind the madness. And then move that also up like that, but not there. We want to make this a certain thickness, so let's go to our back view again. There we are. We want to make this 65 mils. Lock it. Now we can go to the 3D. There we go. That is exactly what we want here. So let's just see if our ladder still works. Let's see. I don't think this was locked. Nope. Let's lock that. Okay. Let's see if we go to our front view and change that to 12 meters. Okay. Everything looks okay. Let's see what the 3D says. No, that is not what should have happened. That should have moved with. Okay. So let's go into our front view. We give this a dimension like that, and that should maybe solve the problem. So it knows that it's linked. Let's just also make sure that it's locked to this specific. Just gonna remove it and just relock it. Okay, let's see if we make that 12. Okay, it's moved it now. Everything is fine. There we go. We constrained that level. That's why we achieved the specific area. Okay, now we want to create the same plate here, but for this specific vertical fixing. So now we can just close all our references here again, just to make our drawings a bit neater. So we're gonna have to recreate this whole plate in the other direction. So we're going to go File, New, Family, then Generic Model. Once this is all set up, it's going to be so easy to use your cat ladder in your project. Okay, so we're going to have to just double check what we've done in the previous set. I want to see if we can maybe copy this over. Let's see. If I say copy, I wanted to paste it here into this reference level. So we go modify, paste, line to current view. See, what it does, it actually pastes the same thing in the same direction, and that's not what we want. So let's just check the basic dimensions. This was 390 centers, and the rest I think I can remember from the top of my head. So we want to draw this in the reference floor plan level, so it's placed onto a certain slab. So reference plane, just a straight line and a straight line, and I literally forgot that dimension. 390, 390, and 390. Now we're going to just create our extrusion. I want a rectangle here. That I want 165 and already 80 mils, which is great. The other direction, going to, I might move a bit fast, but it's exactly the same procedure. It's just in a different plane. So reference plane, that to be 6 mils. So we can lock it there. Okay, there we go. Then from here, we're going to draw the bolts. 12 mil bolts. Just move it back there and down. 25. Mirror it. And mirror that again. Okay. So, okay, go to our back view. Just to adjust our bolts. Want to do it like that. Let's just see if we load this in to our cat ladder, how it displays. Oh, that, I should not have clicked that button, but that's okay. See, this is what we want. So that's just to give you an example that to know that we're on the correct path here. So let's just create the extrusion for this plate was 65 by 10 mils. Move it to here and move that one to, wait, does not want to snap. That one is central, that's cool. Mirror, well, let's say there we go. All good. Let's go back view so we can just edit this plate. We actually don't need this plate now that I'm thinking of it, because the vertical plate is already placed there. So we can just create the stiffener plates. That is 6 mils. And this one we're gonna make 30, or rather 35, because we have a 10 mil plate in the middle. So it's 5 mils on each side. Yeah, that's correct. There we go. DM, mirror around that axis. Right. Go to our back view again. Now we just want to make these plates like that. I think let's make this 60 mils like that. Okay, and then we want to draw in our bolt, or our nut rather. Create similar. It's gonna draw it in randomly again, like that. Move it to the center. Something like this. Gonna mirror that around the axis and mirror those like that. That might look very odd. Just move it into, just maybe display a bit better. You can obviously draw this nut from the standard code. I'm just doing it for example purposes. Give you guys an idea of what is possible. Mirror that. That seems okay. Then we go to the back view and maybe move this bolt also a bit down. And there, lock that one. Okay, let's see if we load it now. We're obviously gonna have to override what we've done previously. That looks better. Click here and then elevation from level. I think it was 12 meters for our cat ladder. So we're more or less in the region there. There we are. I'm gonna move this to the center of that plate like that. Okay, then we must just make sure it's correct in our elevation view. I'm going to say align and align like that. There we go. That looks fine. Let's go and have a look on our 3D view. Looks great. Now we can also change all these elements with this one and those two there. Just change the material category. There we are. See, these ones did not, we haven't changed. So let's just select them all, change them and reload them. So please remember to change them before you load them. Make sure you have it selected as your structural steel. Going to change the other ones quickly. S355. Load it, select it, then load it into our project families. No, sorry, that's only a cat ladder. Okay, let's see what it says to us in our 3D view. There we are. Everything seems to work out perfectly here. Okay, so now that we've done this, let's see if our cat ladder actually works. So let's go family types. We can actually change it from here. Let's make it 6 meters. There we go. Everything snapped with exactly the way we want it to. Okay, so let's just close these tabs. I'm not going to save my families. Like I said, you can save yours. It is basically saved in a way if you save this specific cat ladder family. Okay, so if you guys have checked my previous videos, you would have seen that we've created this 3D structure, or this Revit model structure, and we've gave it some rebar and stuff, but now I've just added in a wall here with a little surface bed on this side, just to show you once we bring in this cat ladder how we can place it and adjust it. Okay, so let's just close this off. Here's our cat ladder. We're gonna load that. Yes, I want to override whatever is in here. Okay, now what we can do is, let's just go to the 3D view. Now I can type in cat ladder here. It's a generic model. I'm gonna pull it in from here. And then if I press spacebar, you can actually rotate between the orientation. But now I forgot to delete the DWG in the background. We don't want that to be displayed. Let's just unpin that and delete it. Load it again. Let's see if we go to the 3D, what happens. Yeah, it's gone now. Okay, so let's go to the roof view. And let's move this section indicator here. And let's move this towards here. So we can see, we draw section 3 here, how it's going to look and how we can adjust that. So I actually must place it more upwards so it actually sits within our wall. So if I go second floor, so you can see the slab, there we go. Let's just move that up. I'm just gonna align it here on the edge. There we go. Okay, go to view now. Okay, so now we can see, okay, great. It is here, but it's not on the correct level. So I'm gonna click on it. We want it to start on the ground floor. So we actually almost have the correct level, which is great. So if I click on this, I can say edit type, and then this screen pops up, and I can edit all these elements that I've created earlier. So now our height is currently at 7 meters, but I'm just gonna, for argument's sake, change it to 10. So you can see it also updates in your model. You can see there, updated perfectly. This height still stays the 2325 that we want. Same with this, you can adjust this, but it's not necessary, but all depends on what you want to see. So if you can recall, we had the cat ladder distance from the bottom of the cat ladder to the top. That's the 10 meters. So if you want to work out to what level we require that height, we're going to say, okay, that's 6 meters that we want the cat ladder at. But this is also 1.1 meters, the extension above. And then here we have a 100. So we're going to have to say 6 meters plus the 1.1 is 7.1. Then we're going to have to minus the 100 mils to get your actual height, which is 7 meters. So if we click on this and say edit, and we type in 7, say okay, you're going to have your correct level there. So yeah, guys, that's how you edit your cat ladder. Thanks for watching, guys. Please like and subscribe if you want to see more videos like this. Cheers, guys.